Hello, everyone. So, let's approach a uh, weird problem, but hopefully, when we get through it, you'll understand how it works. Three congruent spheres are inside a cylinder, such that each sphere is tangent to the other two spheres, to both bases of the cylinder, and to the curved surface of the cylinder. Find the volume of the cylinder given that the radius of each sphere is 12. Okay, now it's a lot going on, but let's examine each shape we're given. Three spheres and a cylinder. These three spheres are inside the cylinder, where each sphere is tangent to both of the bases and the curved surface of the cylinder. Now, when I mentioned spheres in the last problem, I said we should really typically always represent spheres with circles because they're, again, hard to visualize and hard to write out in 3D space. Now, we have three spheres of the same size. They're all congruent with each other. And they're inside this cylinder. And you really got to kind of imagine what's going on. So let's just start by making a circle with a center, and what the radius can be 5. Let's make it a little smaller, like 3. Let's see. Alright, can I just get rid of this then? Let's just, get rid of that and restart it. So radius is going to be 3. And I want each of the three spheres to be congruent. So what that is going to require is that I'm going to have another circle with a radius of 3 and one more with a radius of 3. Okay, now they're all in this cylinder such that the spheres are tangent with the top, bottom, and curves of the cylinder. And each sphere is tangent to the two other spheres. So what that is going to require us to do is have all the spheres that we have so far kind of connect at a single point. So if we get the diagram right, this is what it basically should look like, where cylinder A is meeting with cylinder B at this one point, and cylinder C at this one point. Each cylinder is touching the other two, I should say, at a single point. Now, what we have to do from there is encapsulate these spheres inside of the cylinder. Now, how can we sort of imagine this? Well, if you were to draw a cylinder, it's going to be hard to draw in such a way where you're looking sort of at it from an angle that's not just top to bottom. What we want to kind of visualize happening is we're looking straight down the cylinder from either the top or the bottom. So, let's create our circle, because as we can recall, cylinders all have they have a circular base. So now we can sort of get an idea of what's going on. So here's the 3 spheres, all tangent with the other 2 spheres. And then the cylinder all around it, that would be the circle with the center at D and radius DE. And we notice that each sphere, the smaller circle, is tangent at the side of the cylinder, which is the outline. And we have to imagine it's also touching the tops and the bottoms of the cylinder. Now, it's asking us to find the volume of the cylinder. So what do we need for the volume of the cylinder? Alright, this is super laggy right now, so give me 1 second. I'm just going to copy this diagram because it's basically got what I need right now. I'm going to go back to Active Inspire because it's not insanely laggy. Alright, so let's go over this. Alright, now where was I? Alright, so we're trying to find the volume of the cylinder. So the volume of a cylinder is pi times the radius of the cylinder squared times the height of the cylinder. So what we need to find is the height of the cylinder and the radius of the cylinder. Okay, well, the height we can figure out fairly simply. Each sphere is tangent to both bases of the cylinder, meaning each sphere touches the top of the cylinder and the bottom of the cylinder. And since spheres have a radii, if it's touching the top and the bottom, you can draw a straight line from the top of the sphere to the bottom of the sphere, and that would represent the height of the cylinder. So the line from the top of the sphere to the bottom of the sphere would be its diameter. Now the diameter of the sphere thus is the height of the cylinder. We know the radius of each sphere is 12, which would imply the height is 24. One more time if you didn't quite get that. Each sphere touches the top of the cylinder and the bottom, meaning you can draw a straight line through the sphere that starts at the top of the cylinder and hits the bottom of the cylinder. That line represents the height. That line must also be equal to twice the radius, since from the top of a sphere to the bottom of the sphere would be the diameter of that sphere, and the diameter is twice the radius. So the diameter of a sphere is the height of the cylinder. Okay, now we have to find the radius of the cylinder. Well, that means we need to find from the center point D some sort of length, like from D to E or something. But the only information we're given is that each radius of the sphere is 12. Now, what we could do is make some triangles. And let's start by making a triangle from each of the centers of the sphere, because that should be a fairly simple triangle to work with, because since each sphere has the same radii, all the sides of this triangle would be 24. 12 and 12. Wow. Okay, let's try that again. 12 and 12. 12 and 12. And all the 3 sides would be the same, so we have an equilateral triangle. Okay, well, what does this have to do with the radius? Well, the radius would be like from the center of this circle to this portion here. So I want to find out what that length is, and I'll call this point what do we have? A, B, C, D, E. We'll call it F. So that length we need to find is DF. That would be our radius. Well, what do we know? We know that CF must be 12. This forms a right angle because it's a tangent line. Now, what else can we do? Well, DC is not 12, but from here, I'll label this point here. A, B, C, D, E, F, G. We'll call that G, which that just looks like a 6. That would have a length of 12 because it's another radius of the circle. So if I can find out what this small portion DG is, I'll be set. All I need to find is DG. So the radius I need to find is, well, it's 12 and 12, so 24, plus the length DG. Now, how can we go about finding that? Well, tangent lines imply right angles. So let's see if we can just make some more tangent lines. Well, if I connect D to this tangent point over here, let's say, and let's label that point A, B, C, D, E, F, G, H. Well, because CH is tangent to the sphere with a center at B, that means, again, tangent lines always imply right angles. And now we have a right triangle, DH, and you can't really see it now, but this is a C. Okay. We know the hypotenuse of this is 12. That's the length of CG. Well, the hypotenuse wouldn't be 12 because we have the length DG. But the length of HC certainly would be 12 because that's the radius of the sphere. So we know that CH is 12. Do we know what DH is? Well, not really. Could we possibly find out? Well, I mean, there's a couple ways we could approach this. One example would be, let's try to find, well, this equilateral triangle, right? Where does that come into play? Well, if we were to continue on, we would have a point here, so A, B, C, D, E, F, G, H, I, maybe, I, sure. So we have an equilateral triangle, and its altitude would be CI. Now, what can I possibly get from that? Well, if we can find out what the length of CI is, that means we also have a median of an equilateral triangle. Well, how can I find out what the height is? Well, we know that each side is 24. This is 12. This is actually just it's going to end up being, since it's altitude, that's a right angle. This is 60 degrees, which implies that this angle is 30 degrees. But what do you know? That would imply this angle is also 30 degrees, which means that this angle here is 60 degrees, the one I'm going to mark with 2 angles. I hope you all understand how I got that, because equilateral triangle, this angle at A is 60 degrees. Since this forms a right angle, that means this portion's 30, which means this portion's 30, which means if we look at our right triangle, DCH, it's a 30, 60, 90 triangle. Well, the side opposite to the 60 degree angle is 12, which would imply that DH is, in fact, half of that. No, not half of that. We would have to take, alright, DH is the length of CH if DH was multiplied by the square root of 3. This is just that 30, 60, 90 ratio. CH we already know is 12, so if we divide by the square root of 3, that would give us DH. Dividing by the square root of 3, well, it's the same as we need to multiply like this to cancel the square root in the denominator. That would get us 12 over 3, which is just 4 root 3. So DH is 4 root 3, which means that we have now discovered that DC has to be twice as much as DH because it's a 30, 60, 90 triangle. So DH is going to, DC, sorry, is going to be 2 times DH. So 8 times the square root of 3. Oof. Okay, so what does that tell us? Well, we know D or GC is 12 because GC is a radius of the sphere. So we can now find out what DG is, because DC equals DG plus GC. Now we know DC is 8 root 3, which is equal to DG's length plus GC, which we know, again, it's the radius, so it has to be 12. Therefore, DG is equal to 8 times the square root of 3 minus 12. Okay, putting everything together now to get the radius of our cylinder. We have all the information we need to find that radius. So it's 24 plus DG. We now know what DG is. DG, we have discovered, is 8 square root of 3 minus 12, which implies the radius is 24 minus 12 is just 12, plus 8 times the square root of 3. Now we can finally calculate the volume. So we have the radius, we have the height, volume equals pi times the radius squared, so 12 plus 8 root 3 squared times the height of 24. Alright, time to multiply. So we have pi times 12 squared is 144. Then, oh my gosh, okay, so if we were multiplying out correctly, we would have to do 12 times 8, which is 96. 12 times 8, 96 times 2, which would be 180 plus 12. So plus 192 root 3 plus 8 squared is 64 times 3, which would be 3 times 60 is 180 plus 12 is 192 again times 24. Oh my gosh. Alright, so more calculation. V equals well, we have 144 and 192, so 192 plus 144, that would be 336. Alright, so pi 336 plus 192 root 3 times 24. Alright, almost done. So I am not going to, we're just going to use a calculator for the next part. We should end up getting that 24 times 336. 24 times 336 is 8,064. So that'd be 8,064. Also multiplied by pi, so just put a pi there. Then we have to do 24 times 192. So 24 times 192 is 4608. Pi times the square root of 3. Now that is our final answer. So, a little bit crazy, a lot of stuff to think about. It's challenging just to think about how to draw the diagram. It's challenging just to think, well, you know, how can I find the radius with what I know? And always comes down to triangles. Simple shapes, right triangles, equilateral triangles. Always be thinking about triangles. 3D problems, always try to make them a 2D problem. It's the simplest approach. Even the math, even the calculations were brutal in that one. But if you take your time, step by step, and keep track of your information, don't get too overwhelmed. Write everything you can think of down. You can navigate through these problems and arrive at the solution that you like.